you saw over the weekend, I posted sample questions for MAT125. Those were from last year, but the calendar doesn't change that much. I posted last year's sample final. I just put up the solutions. If you want to check on Blackboard, make sure that it didn't get screwed up. So the solutions should now be up there. I also posted my study guide, if that helps any of you. So it's got some things to concentrate on, review problems, etc. Did I send you that? Ah, you can't see. I can teach on this side. That's not going anywhere. That is definitely a flaw. Okay, I posted that. I also posted the announcement. So once again, if you were at my lecture, or if you were in recitation 1, then you come here for the final on Wednesday. If you are in the others, they're all up there. If you are in, put my glasses on. Okay, ladies, brace yourself. Back the same breath, huh? Okay. If you're in recitation 6, 7, or 8, that Professor Sutherland's class, you go to 102. There. If you're in 9, 10, 17, or 23, you go to Javits 110, and all the rest go to ESS 001, and it's up on Blackboard, so you can write that down. Yes?
UL 17 is ESS 01 and is Javits.
Do I? Do I really?
Yeah.
I hate when that happens. I guess they all go to 110. But we'll double check that. We'll fix that after class, okay? You know, you get old, the lucky you're wearing your pants. Alright. Stuff you guys should be prepared for the final. Okay? Part 1. Once again, but by the way, you all need to know how to do this. Just because you passed part 1 doesn't mean you should now forget this. You should be able to take it to rid of it. You should know do this. Product rule, quotient rule, changeable, have my tangent line. Can everybody see if I write over here? Yeah? Okay. Where does it become a problem? Can you see if I write here? No. Here? Sort of? So there. Alright. Maybe you guys should have sat there. You know? Maybe that's the failure zone over there. I don't know. Alright, so let's see. You should be able to find the maximum and the minimum. Avoid the reflection. Okay, part 2. Alright. That looks like a nice assortment of things you should be able to do. We're going to practice all of these. Or you can take a picture. The last one. Alright. is some antiderivative stuff. So antiderivatives, you're doing the derivative backwards. Okay? So we said you can't see this one? We can't see this one, right? Yeah? You guys have to lean a little bit. So your antiderivative rules. If you start with remember, when you write an antiderivative, you're always going to put a plus c at the end. So if you see a problem like that on the exam, just remember when you're done, just write plus c. Okay? Why is that? Because when you take the derivative of something, there could always be a constant attached, because the derivative of a constant is 0. So if you know that the derivative of something is x squared, you say the original function is x cubed, add 1 to the power, divided by 3. But it could also be x cubed divided by 3 plus 1, or x cubed divided by 3 plus 2. You don't know. It could be all sorts of things. That's why you plus a constant. Okay? I'm going to erase this so I can start working. Okay? If the derivative of sine is cosine, then the antiderivative of cosine is sine. So let's just put a bunch of these up. Let's say we had, and I wanted to find the antiderivative. You could do a capital letter, or you could say this is f prime, and then that would just be f. It doesn't really matter. Very simple. To do the antiderivative of x to the fourth, you do x to the fifth, divide by 5. So you raise the power by 1, divide by the new power. Okay? Think about it. When you take the derivative of this, the 5 comes down and cancels with this 5 times x to the fourth. So the antiderivative is going the other way. You're going to need this right away in 126, but I'll review it. Okay, what about the derivative of the antiderivative of cosine? Well, the derivative of what is cosine? The derivative of sine is cosine. So the antiderivative of cosine, sine. When you do these, always check. Say to yourself, I'm going to differentiate this, and I have to get back to here. The derivative of log of x is 1 over x, so the antiderivative is 1 over x. Log x plus c. Convince yourself this is true. Take the derivative. Okay, look at this. You take the derivative. Derivative of 5, x to the fifth over 5 is x to the fourth. Derivative of negative 2 sine x is negative 2 cosine x. Derivative of log of x is 1 over x. Derivative of c is 0. What if I had e to the 6x plus 5? And I want to find the antiderivative. Well, what's the derivative of e to the 6x? It's e to the 6x times 6. So the antiderivative would be e to the 6x divided by 6. Think about it. You have to do the chain rule. You take the derivative of e to the 6x, you get e to the 6x times 6, so dividing by 6 gets rid of that. What's the antiderivative of 5? Who's saying 0? So you go all wrong if you say 0. Instead, it's 5x. Go the other way, because the derivative of 5x is 5. Okay? You have to be careful you don't confuse that with derivative. If we have the derivative of pi is 0, but the antiderivative of pi is pi times x. Okay? Plus 6, of course. I have some other equally unpleasant ones. I made some notes. Compare once in a while. antiderivative of that? Well, notice, q root of x looks really scary, but that's just x to the 1/3. So to do the antiderivative of x to the 1/3, you're going to add 1. What's 1 plus 1/3? 4/3. So this would be 4/3 divided by 4/3. You could leave it like that. You don't need to show off how good you are at simplifying. And what about 1 over the square root of 1 minus x squared? That is inverse sine, or arc sine. I put that on my little review sheet, which I posted on Blackboard. Did anybody check Blackboard to make sure those things are active? Are they up there? One of you please check, because I can't do it from here. All right? And what about the antiderivative of pi cubed? Pi cubed x. Because the derivative of pi cubed x would be pi cubed. Can you see that? If you guys are having trouble seeing, you might want to squish it towards the center. I don't know how professors teach here without a blackboard. They don't use blackboard. They do everything up there. Oh yeah, that's not happening. I mean, that would require me to prepare. You guys all remember your derivatives, right? No? Let's practice a couple more of these, and then move on to something else. Good enough. Okay, practice that for a second. Let's see if you can figure it out now. Yo. It's working. Oh, it is? Wonderful. You get an 8 month. I did. Okay. You good now? Okay. Missing like one. You sign. Are you okay? You sure? So let's do this. What's the antiderivative of cosine of pi over 2x? Sine of pi over 2x divided by pi over 2. Why do I divide by pi over 2? Just think of it as the chain rule factor. Okay? Because if I take the derivative, I'm going to be multiplying by the derivative of the inside, which is multiplying by pi over 2. So the antiderivative is divide by pi over 2. That's not that hard, right? This is in chemistry. Alright. Antiderivative of 3x squared is 3x cubed over 3, or if you're clever, x cubed. Because the derivative of x cubed is 3x squared. How about e to the 2x? E to the 2x over 2. And what about 4 over x? Well, 1 over x is natural log of x, so this is going to be 4 ln of x plus 2. Don't forget the plus C. How much fun was that? Okay? Yes? You don't understand why divide by pi over 2. Take the derivative of sine of pi over 2x. Take the derivative. You get cosine of pi over 2x times pi over 2. But we only have cosine of pi over 2x. We don't have the pi over 2. So we want to get rid of that. So that's why we divide here. Because now, if I have this over pi over 2, those cancel. Okay? Because you don't need to use the quotient rule for that. Diana, hold up your hand. Okay. All right, question.
So would you want us to like cross out 3x to the third over 3?
You will not require to simplify anything.
Okay, so we can leave it 3x.
You could leave it 3x cubed over 3.
Okay.
Okay? The only reason to simplify is to make your life simpler. If it doesn't make your life simpler, don't bother. Okay? It's our job to figure out what you did, and if we're not sure, we'll just mark you wrong. Okay. That was a joke. You stress. Okay. Nice job. All right. Let's do some optimization problems. We love those. Okay, the word problems are the hard part, because you have to figure out how you're going to set things up. You're aware of this. So let's do a couple of word problems. Okay. Now, in the interest of time, I'm going to do this with you guys, because I know how much you want to do it on your own, but we're going to share. Okay? So we look and we say we have a soda can that's going to hold 240 cubic centimeters of soda. Is that a lot, by the way? You guys have been taking chemistry. Is that a lot? Yeah, about 8 ounces. It's an 8-ounce soda can. That's not a lot. 8 ounces of Red Bull, but not 8 ounces of soda. Okay. The top costs 6 cents per square centimeter, because the top is more expensive. The rest costs 4 cents per square centimeter. So minimize the cost of the can. So you look and you notice, pay attention to the units. Cubic centimeters is volume. Square centimeters is area. So I'm going to need to use volume and area to find a way to make the cheapest possible soda can. The cheapest soda can will be the soda can with the smallest area, factoring in the costs of the area. That makes sense, right? Because the area is a piece of metal that I need to bend to make it into a soda can. So I have 2 pieces of information. I also have a cylinder. What's the formula for the volume of the cylinder? can see somebody's raising their hand and asking, will we need to know that for the final? Somebody's hand is up. We will give you geometry formulas if you need them. Okay? We may not use more geometry formulas than you need, but we will certainly give you the formulas you need. But let's be honest, folks. You should know how to find pi on the cylinder. It's not that complex. Surface area. Well, for the surface area, you need the area of the tube. That's 2 pi r h. Then you need the area of the top and the area of the bottom. Those are both pi r squared. But we're not quite doing the surface area, we're doing the cost. So it's a little different. All right. For the volume of the can, pi r squared h has to equal 240. And what's going to be the cost of the can? Well, let's see. First, I need to put the top on the can. The top is a circle, a solid circle. So it's going to cost 6 cents times pi r squared. Right? Got to make the circle on top. So that's 6 cents times the area of the top. The area of the bottom is only 4 cents times pi r squared. Then the area of the tube of the cylinder, the cylindrical shell, as we're going to call it in 126, is 2 pi r h, and that also costs 4 cents. So the cost is the equation we're going to minimize. So that simplifies 10 pi r squared plus 8 pi r h. 10 pi r squared plus 8 pi r h. Now we're going to take those pieces of information, put them together, take a derivative, set it equal to 0, and solve. But hey, setting this up is worth a reasonable amount. Okay? So learn to set up the problem. If you do the correct setup, you'll get something. I can't promise you how much credit you get, but you'll get something. All right. So we're going to use this equation to help get rid of one of the variables. Because the problem we have right now is we have 2 variables. We only want 1 variable. So let's rewrite this as h is 240 over pi r squared. And then I have to plug it into h in the cost equation. The cost will now equal 10 pi r squared plus 8 pi r times 240 over pi r squared. Professor Kahn, what if we mess up the arithmetic? We'll look at your arithmetic. That's why we have partial credit. Okay? This is part 2, not part 1. And you won't multiply 8 times 240? That's why you have paper and pencil. Or a pen, if you're a copy. So 8 times 240 is 1920. One of the pi's cancels and one of the r's cancels. So you just get 1920 over r. Okay? So far so good. Now you take the derivative. I'll put the derivative over here so people on one side of the room have trouble seeing it. So c prime is 20 pi r minus 1920 over r squared. And we set that equal to 0, of course. So how do you set that equal to 0? Well, you can multiply 2 by r squared, and you get 20 pi r cubed minus 1920 equals 0. How did I get that? I multiplied by r squared. So that gives you 20 pi r cubed, and the r squared and the r squared cancel. I'm allowed to do that because I know r will not be 0. Yes?
Can you write bigger? I can't really see the board.
No? Sure. How's that? 20 pi r cubed minus 1920. You solve that, you get r cubed is 1920 over 20 pi r cubed root of that. Now think about it, okay? You're not going to have a calculator in the exam, so we can't give you a number that would be very uncomfortable like this number, okay? Got to give you a nice, simple number. Because cube root of 96 over pi is messy, right? So we wouldn't give you something that's quite that bad. But once you've got r, then you plug it back in and you get h, and those are the dimensions that give you the minimum cost of the can. Okay? So if we were to give you this, we'd probably just ask for the radius. Okay? Of course, we're not going to give you this exact problem, because that would be too easy. Yes? Why is that minus 1920 over r squared? Well, do you remember what the derivative of 1 over x is? What is it? So the derivative of 1920 over r is negative 1920 over r squared. Got it? You could also write it as 1920 times r to the negative 1. Okay? This is 1920 r to the negative 1, so the derivative is minus 1920 r to the negative 2. That is minus 1920 over r squared. Okay? Good? Let's do some more. Yes?
What are you doing with the step when you make it equal to 0?
What am I doing in which step?
You're making it equal to 0.
From here to here?
Yeah.
Now I told you guys, how do they get from here to here? Okay, I multiplied everything by r squared. That makes this 20 pi r cubed, and that r squared cancels with this r squared. Okay? Yes?
After you when you were equating what and where you got c equals
Okay. Where does the cost come from? The cost at the top is pi r squared, that's the area at the top, times 6 cents. Pi r squared is the area at the bottom, times 4 cents. And 2 pi r h is the area of the tube, times 4 cents. Okay? Question? What happened to the h? You tell me. What did I do? I took h and I made it 240 over pi r squared. And I went to this equation right here. And I replaced h with 240 over pi r squared. That was this long. Okay? And that reduces to this. Okay? I took h and I substituted 240 over pi r squared. Okay. Other questions? You can watch it again on video. And again and again. Maybe this will be the YouTube highlight of the week. Only if I fall off the balcony. Then it'll be the YouTube highlight. Okay, when can I erase? I'm going to erase in 5 seconds. And I'm erasing. Okay. A swimmer is located 300 meters from a straight shoreline. So, what does that mean? When you do these word problems, break it down. Okay? You have a straight shoreline, you get the swimmer sitting somewhere there, 300 meters away. 1,000 meters down here is the ice cream stand. Yum, ice cream. I'm in the mood for ice cream. All right. She can swim at 4 meters a second and she can run at 6 meters a second. So if you think about it, this is the fastest distance to the ice cream stand, but she'd be swimming the whole way. She doesn't swim as fast as she runs. She could get to shore as fast as possible and then run because she runs faster than she swims, but now she'd be going the biggest distance. So somewhere in the middle is the best place to land. Okay? Again, she could go all the way from here to here. A hypotenuse. That's the shortest distance, but she swims slower than she runs. She could do the maximum distance, which is swimming the minimum distance, and then running the whole way, because she runs faster than she swims, and she's doing the biggest distance. So somewhere in the middle is the best place to land. Where is that place? He's going for ice cream. Okay. How are we going to find the shortest time? Well, remember that rate times time equals distance. Or time equals distance over the rate. So we can give you this problem with running. We can give you this problem with all sorts of variations. But the basic idea is, where's the best place to make the hypotenuse hit? Okay, so this distance. So let's think about what the swimmer is going to do. She is going to first swim from here to x. So that distance is the square root of 300 squared plus x squared. So she's going to go the distance 300 squared plus x squared. And time is 300 squared to 300 squared plus x squared divided by 4. Now she's on land. Now she's going to run as fast as she can, which is 6 meters a second, which is not that fast. She's had too many ice creams in her life. Okay? That distance is 1,000 minus x, and she can run at 6 meters a second. And you put those together, and that's the time. And that looks scary, but it's really not that bad. Can I erase the word problem part now? Everybody got it? It's going to be on video later.
That's a minus between the.
I can't hear you. What?
That's a minus between the 1,000 and X.
That's 1,000 minus X. Okay. All these people who criticize my handwriting, where were you when I did the penmanship lesson? Can you hear me when I talk to the board, by the way?
Yeah.
Okay. Serena can. You can hear me. Okay. Who said no? Who said they can't hear me? Now you can hear me. Okay. Don't worry, you're not missing anything at grade. Trust me. All right. So I'm going to rewrite this. Time is this plus this. Now let's write this in a slightly better way. That's 1/4 times 300 squared plus x squared to the half. 1/4 times 300 squared plus x squared to the half. Because this divided by 4 is the same as times a quarter. You don't need to use the quotient rule. This divided by 6, well that's 1,000 divided by 6 minus x over 6. 1,000 divided by 6 minus x over 6. Am I projecting okay? Can you hear me up there? Can you see me? Hi. Okay. Let's take the derivative. T prime is 1/8 300 squared plus x squared minus a half times 2x. That looks scary. Don't be scared by that. What's the derivative of 1,000 over 6? It's 0. That's a constant. And what's the derivative of x over 6? You do not need the quotient rule. It's 1/6. Okay, you guys put a lot of energy to do a quotient rule on the part 1 of the exam. You don't need the quotient rule for those kinds of things. All right. How are we going to solve that? Well, first of all, the minus a half means 1 over the square root. So this is now 2x over 8 times the square root okay? The 2x goes in the numerator. This goes in the denominator because it's a negative 1/2. And this is in the denominator because it's a fraction. Minus the 6 equals 0. Got any ideas on how to solve that? Put the 1/6 on the other side and cross multiply. Cross multiply and you get 12x equals 8 times the square root 300 squared plus x squared. The worst part of calculus is the algebra, not the calculus. Okay. Where do we go from here? Well, we can divide 2 by 8. Divide both sides by, I guess, by 4. I'm going to erase this. Divide both sides by 4. And you get 3x, 2 radical 300 squared plus x squared. And now square both sides. You get 9x squared equals 4, don't forget to square the 2, times 300 squared plus x squared. This is rapidly becoming easier than it looks. The 9x squared is 4 times 300 squared. If you're not comfortable with what 4 times 300 squared is, leave it alone. Plus 4x squared. Subtract 4x squared and you get 5x squared. This is 4 times 300 squared. And now divide by 5. to the 4 times 300 squared over 5. So x is the square root of that. What's the square root of 4? 2. What's the square root of 300 squared? 300. The square root of 5 is square root of 5. Okay? Boy, it's a lot easier when you watch me do it, isn't it? You're sitting there saying, no way. Look, if you can get to this step and to this step, that's most of the work. Okay? That's what we're looking for. We're looking to see if we can set it up. We're looking to see if we can take the derivative properly. I've got a chart. There's now a 10-point question. To me, you've got 7 or 8 when you get to this step. Then I want to see if you can solve it. It's worth something, but it's not worth too much. Maybe I would make it 7 and then 3. Yes?
Why did you divide by 4?
Oh, why did I divide by 4 instead of 8? I didn't want to have a fraction. Because 8 doesn't go to 12. Good. You don't have to divide at all if you don't want to. The key is, this looks really scary. Okay? And this isn't very scary at all. So you have to get from the one to the other. Okay, so that's a couple of optimization problems. Now let's do a couple of related rate problems. Love related rates, right, Diana? So much. I don't know about you guys, but all of this stuff is exhausting. You guys have no idea what it's like to be tired and stressed. Yes.
That answer would be unit of time per second, right?
That would be, that's not second. That's not a unit of time. That was the question. 2 times 300 over the square root of 5 is the place on the beach where you land to get there at the shortest time. So remember,
Distance?
it's the distance. So you're landing at the place 600 over the square root of 5 meters. Okay? You are landing at the spot 600 over the square root of 5 meters. Then from there, you run the rest of the way. For those of you who do biathlons. That gives you the shortest amount of time. Okay? So you get to the ice cream stand the fastest, get your ice cream, get home, start eating. Or maybe you eat it right there on the beach. Alright. Should we do a couple of related rate problems? Because we love those so much. Every day is an opportunity for sarcasm in college. Every day. Alright. Can I start erasing? Lila, can I erase? Okay. It'd be really nice if I could use the whole board. Remind me never to teach class in this room. Okay? Let's do a related rate problem. Let's see. Okay. A spherical balloon is increasing in volume at 60 pi cubic inches per minute. How do I know its volume? You guys take chemistry, pay attention to units. How fast is the surface area increasing when the radius is 6 inches? Okay. So volume of balloon, volume of the sphere, is 4/3 pi r cubed. Surface of the sphere is 4 pi r squared. Next semester, maybe you'll learn where those formulas come from. Because because I know you really were wondering. Were you really wondering? No. Yes? Okay, I'll put it on the final next semester. Okay. How fast the surface area is increasing? So we're going to need to relate the rate at which the volume is increasing to the rate at which the surface area is increasing. That's why it's called related rate. We also know that the volume, VT, the volume is increasing at 60 pi. We want to find the SDT when R equals 6. That's what we're looking for. So what do we do? Well, let's calculus class, take the derivative. How do I know it's dDTs, all these dTs? Because it's rates. So I have volume is 4/3 pi R2. The problem is volume is in terms of R. And I asked for when the radius is 6 inches. But I want to find how fast the surface area is increasing. So what I could do is I could rewrite this as S over 4 pi square root R and plug that in there. I don't want to do that. Way too much work. Some of you who write incredibly quickly are already erasing that. Serves you right for going so fast. Or I could do this part of the problem separate from this part of the problem. That's what I'm going to do. I'm going to do the volume separate from the surface area. You guys can hear me? Good. So dVdt is 4/3 pi times 3r squared dr dt. Notice, no product rule. 4/3 pi is just a constant. In fact, it's around 4. Okay? So it's just that constant times the derivative of r cubed, which is 3r squared dr dt. And over here in the surface area, I get ds dt is 8 pi r dr dt. So I can go to this equation on the left, solve for dr dt, because I know dv dt is now r, and then go to this equation, plug in r and dr dt, and I get ds dt. It's really not very hard after you do it. So these 3's cancel to make my life easier. And we said r is 6, so 60 pi is 4 pi times 6 squared dr dt. The pi's cancel. And you get 60 divided by 4 is 15, divided by 36 is 5 divided by 12. So the r dt, I guess I'll put it down here, is 5 over 12 inches per minute. So if we just ask how fast the radius is changing, you'd be done. It's 5/12. But we're not that nice. So now we ask for how fast the surface area is changing. Well, all I have to do now is plug in. It's 8 pi times 6 times 5 over 12. That gives you 20 pi square centimeters per minute. Okay, not so bad. All right, let's do another related rate problem. Yes?
Is it supposed to be squared converted?
Oh, yeah, h is squared. You are correct. If you wrote centimeters squared, we wouldn't take off. In fact, I don't think we're going to ask you for the units. We should, but I don't think we will. Okay? I think it's important to get the units right, but this is math. Principles what matters. We say the units for what class? Chemistry. Are there any opportunities for sarcasm in chemistry class? Maybe once in a while. Okay. Can I do another related rate problem? Sure. Where are you two going? Hi. Off to get ice cream? Give me 1 second. Okay. A conical tank has a radius of 6 meters and a height of 18 meters. It is filling with water at 12 pi cubic meters per minute. How fast is the height of the water rising when the water is 6 meters high? So you have a conical tank. You dump it in water. The radius of the tank is 6 meters. And the height of the tank is 18 meters. And you want to find out how fast is that water level rising. Okay, what's the formula for the volume of the cone? It's pi r squared h over 3. What's the formula for the surface area of a cone? Who cares? We didn't ask you for surface area. Okay? What's the formula for the volume of the cube? We didn't ask you that one either. Alright. So how fast is the height of the water rising? So what do you need to relate the rate that the height is increasing to the rate that the volume is increasing? We know that the volume is increasing at 12 pi, We want how fast the height is increased when the height is 6. So if you look at this equation, pi r squared h over 3, you have an r, we have an h. We want to find the h dt. So if I take the derivative of this, the problem is I have two variables. I have r and I have h. So I'm going to have to use the product rule. And I don't know the r dt. So that's annoying. So I'm going to use the information about the cone to remove the radius from the problem. So the key to the cone problem is that the ratio of the radius to the height is always the same. The radius divided by the height is always 6 over 18. It's always a third. For r, equals h over 3. So I can use that information now and plug that into the formula for the cone. Define the cone is pi r squared h over 3. I'm going to rewrite that as 1/3 pi r squared. R is now h over 3 squared times h, which can simplify into pi. H squared times h is h cubed. 3 times 3 squared is 27. Take everybody the ice cream idea, they're all late. Never gonna say ice cream on a date. Never gonna say. Alright, dv dt. Pi over 27 is just a constant. Times 3h squared dh dt. Now I just plug in. Because I said h is 6. I know dv dt, I just have to find the h dt. So I get dv dt. Whoops, dv dt I know now, sorry. I get 12 pi is pi over 27 times 3 times 6 squared dh dt. I hope you can all see that. I'll rewrite that over here. That's too hard to see. You get 12 pi is pi over 27 times 3 times 6 squared dh dt. Why do I put the pi in the volume? So you cancel it. You get 12, 3 times 6 squared over 27, or 4. So the HGT is 3. 3 what's? Well, I have to get the units for it, but it doesn't matter. It's 3. How are we doing so far? Exhausted? Ready for chemistry? No? Ready for biology? Physics? Nobody here's taking physics, right? Physics is really fun. No? Well, I can keep going for a little while longer. Yes? Okay, go over part 1. Oh, I'm not going to go over part 1 here. I did that at the review on Monday. It's on video. One more related rate? You guys want one more related rate? I'm just a graphic problem. What? Oh, velocity, acceleration stuff. No. No, just basic derivatives. I mean, I'm not going to get to cover everything. I'm sorry. I can sketch a curve. Want me to sketch a curve? Should I do something else? What are you voting for, love? I'm holding. I'm not necessarily going to do what she wants, but just what I'd ask. No, it's good manners. Five, 4, 3, 2, 1. I can't hear you. So, let's make sure you guys can do a curve. Maybe a curve involving a logarithm. Oh, they'll be calm? I'll do one of those in a minute. Hi, ladies. Say hi to the sisters. Alright, how about a nice, not too crazy graph? Go down, go graph. This is draw this graph. All right, we're going to sketch this curve. Boy, I turn around and you really have to hurry. Too bad, don't you? You don't listen anyway, right? You never like those people. This is what I give away all the secrets to the final. I just need a few more of you to read. And then I'm going to start saying this will be problem 5 on the final. So the next semester I'm going to do my word thing. Maybe. I might do that. I can just do a word for coming to class. Yeah, and it's not going to be videotaped next semester as far as I know. Or video, whatever that is. Video. Alright. 120, this is 125. 126, as far as I know, they're not going to be recording my class. They might. If I'm in a place where I can turn on echo, I might, but I might not. You should show up once in a while. Yeah. Some of you come to every single class. You should be recorded. Some of you don't come to every single class. You shouldn't be punished, but you should not be recorded. Just ask that. Alright, let's take the derivative. Why do we take the derivative? This is calculus class. We get 6x squared minus 42x minus 48. We set that equal to 0. Divide through, factor out a 6. And that factors very nicely. So that means we have critical numbers at 8 and -1. Now what do? We do a sign test. Pick a number to the left of -1, like -2. Plug in the derivative, and you'll get a positive value. Pick a number between -1 and 8, like 0. Plug it in, you get a negative value. Pick a number greater than 8, like 9. Plug it in, you get a positive value. The curve is going up, then the curve is going down. The curve is going up. How are we doing so far? Can you repeat that? Which part? Cornwood? The sign testing? Yeah. You pick a number to the left of -1, such as -2. Plug it into here, the derivative, or any part of the derivative. You get a positive answer, that tells you that the curve is increasing here. You pick a number between -1 and 8, like 0. You plug it into the derivative. You get the negative value. This comes out negative. The curve is going down. You pick a number bigger than 8, like 9. You plug it in. You get a positive value. The curve is going up. Okay? It's going up, down, it's going up. Okay. Now we need to do the second derivative. The second derivative is 12x minus 42. Set it equal to 0. That's you get 7/2, also known as 3.5. But since most of you are even worse with decimals than you are with fractions, I'm probably going to leave it as 7/2. Okay, sign test again. Pick a number less than 7/2, like 0. We love 0. Plug it in, you get a negative value. The curve is going down, it's concave down here. Pick a number greater than 7/2, like 1,000,000,000. Plug it in, you get a positive value. The curve is going up there, it's concave up there. Okay? Alright, now we know the shape of the graph. We know where the maximum, min, and the point of inflection are. We have to figure out the actual values. So we have a maximum here at x equals -1 because the curve is going up and it's coming down. We have a minimum at x equals 8, and we have a point of inflection at x equals 7/2. Now look, on the exam, it's entirely possible that you'll screw up when you plug these values back in to get the y coordinates. Show your work. Okay? If you have the shape of the graph right and you have the x coordinates right, we're not going to punish you if you can't get the y values exactly right. But you should be able to plug -1 in successfully. You get -2 minus 21 is minus 23, plus 48 is 25, plus 10 is 35.
Before x equals 7/2, what is it?
Here?
No,
Point of inflection.
oh,
Person of interest in the FBI world, point of inflection for the rest of us. Okay, 8 is a huge number. We're not going to ask you to find it, okay? But you can all do 8 cubed, that's 512, that's 1024. Minus 21 times 8 squared, which is 1344. So now you're down to minus 210. Minus 48 times 8, which is minus 384. I forgot to get the number with it already. Anyway, it's a big number. It goes way down. So, what does this graph look like? Something like that. Okay? That's x equals -1. That's x equals 7/2. That's x equals 8. We're not that concerned with what the y value is. Okay? Wow. Handwriting is really long. Okay? If you label it like that, that's fine. And I'll tell the GAs that's fine. Or we'll make the numbers come out easy. That's possible. All right. Who wanted to go to the hospital? Was that Lola? You wanted a hospital rule? Also known as l'hôpital. We like to say in French. to find that limit. Well, I plug in 0. And what do I get? I get 0 on top. I get 0 at the bottom. That makes me really sad. So I write the limit does not exist and I get no credit. Or, what do I do after? I heard you sneeze. I think you were awake. What do I do? L'Hopital. What's L'Hopital's rule say? Correct. Derivative at the top, derivative at the bottom. Perfect. Not the quotient rule. The derivative at the top, the derivative at the bottom. Now I plug in 0. Gotta love the unit circle. What's the cosine of 0? 1. So this is 10 times 1 over 7 times 1. Also known as 10 over 7. What if I wanted to find this? The limit as x goes to infinity, log x over 3x squared. Well, when I plug infinity into the top, I get infinity. When I plug infinity into the bottom, I get infinity. So I use L'Hopital's rule. Alright, what's L'Hopital's rule? Take the derivative at the top and the derivative at the bottom. There you go. Same limit. Derivative of log of x is 1 over x. Derivative of 3x squared is 6x. That's the same as, think of that as 6x over 1. Over 6x squared. Okay. What's the limit as x goes to infinity of 1 over 6x squared? 0. You guys can do this stuff. You can pass this final. You can do well. You have to stay around. They didn't run off for ice cream when my back was hurt. I know who those people are, okay? Right? Let's do some more. I won't do too much more. We'll do about 10 minutes. You guys are running out of steam, and frankly, so am I. Studying. Is it on fun? Sorry? I did not. I apologize. Yes. L'Hopital's rule will be on the final. Oh, we won't tell you these. Oh, yes. Let's do this method problem. Actually, I don't feel like doing this method problem. I'll leave that for another day. All right? Why don't you just do it on your own? You have it? No. See? All right. Pretty cool, right? How do we do this? What's the root of x cubed? 3x squared. Okay? Okay. Now for the fun part. This is the part you will mess up. You have to do the middle. And that's the product rule. And notice the minus sign. I love to use the minus sign. Product rule. Derivative of 3x squared y squared. Well, take the derivative, take 3x squared, leave it alone. Multiply by the derivative of y squared, which is 2y dy dx. Plus y squared times the derivative of 3x squared, which is 6x. Close parentheses. That minus sign is going to get distributed. This is going to be minus, and this is going to be minus. Then the derivative of 4y cubed, which is 12y squared. dy dx, and that equals 0. Getting to there is most of the way. Now, you have to isolate dy dx. So distribute the minus sign. You get 3x squared minus 6x squared y dy dx minus 6xy squared plus 12y squared dy dx equals 0. All I did was distribute the minus sign and clean it up a little bit. Now remember what we do. We group the dy dx terms on one side and the non-dy dx terms on the other side. So you get 3x squared minus 6xy squared equals 6x squared y squared dy dx. Now I can factor out dy dx. And I get 3x squared minus 6xy squared equals 6x squared y minus 12y squared all times dy dx, and I divide. Okay? How was that? Alright, I sense the natives are getting restless. Yes?
Can you just keep the negative in there when you're doing the product rule?
You keep the negative in there when you're doing the product rules. As long as you get the right answer, there's more than one way to do the other.
Get the right answer.
Well, then yeah. Watch your mind aside. Alright, I've had enough. So, study hard. I put up my office hours. Otherwise, study. There's lots of practice material online. Fix the recitation rules. Alright,